I'm here today to present an AI project that I recently completed. My goal was to use computer vision. This was sort of part of a lab that we did when I was in the cohort.
I'm going to get started. I'm very excited today because we're going to have one of our alumni members presenting today in our community. I think this is kind of like a new step in our AI product management community, a new chapter in our AI product management community, in a sense that we're starting to kind of reach this point where the quality of some of the community members, also with the help of the cohort, is reaching a level where they can come in and like kind of present, what they're working on or share a new perspective. And this is really good. I think it's good for all of us, and hopefully over time we'll get better as we learn from each other. So with that said, I want to pass this to Adam. I'm very excited for that. And Mahesh is also not joining us today. He's attending some, I think, talk in one of the universities in the East Coast. If anybody remembers which university, feel free to
MIT.
share. Is it MIT? Okay, yeah.
Yeah. Yeah.
So he's busy this weekend, but very, very excited to have Adam present today. So with that said, I'm going to pass it to you, Adam, and let me give you share access as well, so you can actually.
Thank you.
Um, wait, oh, there you go. Okay, perfect. So I just gave you share access, and I'm going to put myself on mute so you can take over.
Awesome. Thank you so much, Bijan. I appreciate it. What you and Mahesh are doing here. And thank you for letting me be sort of part of the new evolution of this cohort where, hopefully becomes more collaborative, and I'm not more and more people are sharing the projects that they've worked on. So thanks again for that. So like Bijan said, my name is Adam. I'm a product manager. I work mostly in the entertainment space. Currently I'm running a small consulting firm, deploying some AI solutions for very small agencies. I'm here today to present an AI project that I recently completed. My goal was to use computer vision. This was sort of part of a lab that we did when I was in the cohort. And so the idea is using computer vision with data supplied by a home security camera to detect packages at my front door. I'm going to show you how I did it, the tools I used, and hopefully by the end, you'll all be able to, do the same thing. I'm going to walk through the tools in a second. And then before that, I'll just give a brief demo just to show you basically how it works. And then after I run through sort of how I set it up, I'll kind of like give you a tour of the tool, show you how to train the model, how to use your camera, improving the model using inference metrics. And then after that, I'll just we'll spend some time highlighting some of the challenges that I faced personally on this project. And I'll also just say in advance that if anybody works on this or is running into any problems, please reach out. It took me a really long time to figure this out. I'm not a technical product manager, and I felt like my DevOps skills would have like really come in handy here. And I definitely did not have those. So it was a lot of GitHub, a lot of Stack Overflow, just to try to figure out what I was doing, but finally figured it out. Also, Chris Lincoln, who is on this call, definitely pestered him and Niraj a whole bunch of times, asking them for help. And so thank you guys for helping me. So I'm just going to share just a quick video of let's see, what's the best way to do this? Hold on one second. Let me see if I can get sharing happening. Please be patient with me. Oops. So So if I share this screen, can you all see my screen? All right.
Yep.
With this video over here.
Yep.
Okay, cool. So this is the project. Basically, this is a camera that I have at my front door. This is a video of me delivering myself a package. And the idea is essentially when I get boxes put in my front door, I get a little detection noted, hey, there's a box at the front door. So I want to start by talking about edge computing and AI. Obviously, in case it's not obvious, this is a no-code solution that uses a Microsoft product called Custom Vision. Can you guys still see my screen? All right. Okay, cool. I'm just gonna
Yep.
tab around. So if anybody can't see anything, just let me know. So I just want to show you Custom Vision. So this is Microsoft's vision service. It lets you build and deploy your own image models. Out of the box, it's very kind of quick to show how powerful this tool is. I've created some models here, but there's actually some out of the box models just to demonstrate it. But I'll just kind of show you real quick. So this is one of the models that I've created, and I'll kind of go into this, and you can see that all of these images have been tagged. Just as an aside, my wife and kids think I'm absolutely crazy because I taped up a bunch of empty boxes to train this model, and I have about 500 I have about 500 photos of boxes here that I used to train. So that was definitely a challenge in some way. And I'll just kind of show you a quick test. This is super easy to use. But if you kind of just I have just a whole bunch of photos of boxes in here, and just to run some inference really quick, and you can see that it very quickly recognizes this is indeed a box. You can change your threshold hold value to pick up various things if you want to get your model to be a little bit more precise. But very, very easy, really great tool by Microsoft. And it's easy to sort of plug and play, so to speak. So the final project uses an open source project that's leveraging custom vision called Vision on Edge. Hold on one second, sorry. And Vision on Edge is actually an open source project that Mahesh created. And it utilizes edge computing and Azure IoT Hub to bring a customer's vision project to production using their own data. And so that's the idea with this project. I'm using my own data, using my camera at my front door, and processing it on the edge, quote unquote. And just real quick, I just want to talk real quick about why AI on edge, why is that important? And sort of what are the general challenges, and I'll talk about my own sort of how my own personal challenges fall into this a little later. But I think the big benefits obviously are going to be real-time processing. You have lower latency. That means faster, potentially safer, depending on what kind of solution you're employing. For scaled solution, that could be a higher accuracy for decision making in a factory setting, which I think is what a lot of people are utilizing this tool for. They're resource efficient by design. They're efficient because there's limited capability on the edge for devices in compared to the cloud. That's not always the case, but oftentimes it's the case. They're scalable. So scaling via adding more devices increases your data collection. There's great redundancy, so you can provide failover capabilities in case devices fail or servers fail. They're cost effective potentially, although there is sort of a trade-off there. So while you save on bandwidth to the cloud, there may be like additional costs associated with deploying hardware on edge. So it's a little bit of like horse trading. I don't know if I'm sure some of you have experience with this. So it really depends on the application, and you just kind of have to decide on what's the best thing for your product. I would say some of the biggest challenges. So data quality. This was certainly a problem that I had. So, especially if you have cameras that are like, or sensors in general that are just like noisy or just don't have like great quality, you could get like inconsistent data, which means like the quality of your model is, it's less reliable, it's less accurate. Security and privacy are things that, again, it's a little bit of horse trading. It does sort of remove transferring data to the cloud, but it also adds in some insecure points where people can actually have physical access to your devices on the edge. So again, it really depends on the application. Um, Model optimization is the next thing. So due to the limitations with compute or memory or storage on the edge, models that are built for the cloud need to be reduced with some kind of reduction methodology like quantization, which I don't know if everyone in the group's talked about, but it's just a very interesting way to reduce the size of models for like edge computing. I would say that while this could restrict the complexity of models, but there's been some very good advances in model reduction, like a lot of really interesting techniques. So, it's becoming less prevalent, I would say. And again, if anybody has personal experience with this, I'd love to hear more about it. And then scalability, I think, it's again some horse trading here, but like while scale, it could be simpler to scale, but you're also talking about managing a bunch of devices on the edge, and they might not be consistent. They may not be the same device. You may be getting various types of, you might be getting different types of signals scaled in different ways. So it really depends on the solution. And I think this is another area where there's been great strides. I don't know if I have the ability to call on someone, but Sujit, it looks like your
Yeah, go
hand.
ahead.
Hi, a quick
Go
question.
ahead, Sujit.
With
Yeah.
a quick question. You mentioned something about model reduction. Could you double click on that, please?
Sorry, say that again.
You mentioned about model reduction.
Yeah.
Could you elaborate a little bit more on that?
Yeah. So, we have these huge models, right, that are generally built to work on the cloud. And if you're building out a solution where the processing power of your model is actually happening on an edge device, like a dev kit, like a NVIDIA or an IBM, smaller device, you just generally have less compute, less storage, less memory. And so your model has to be reduced in size in some way to work effectively to have an acceptable amount of accuracy. So again, when you're sort of trying to solve for your particular problem, you really need to like make these considerations, like what is the level of accuracy that we need? Are there reduction methods that will be appropriate for the solution? How much reduction is acceptable in order for us to still like maintain the type of inference that that we need in order to like be successful. Does that make sense?
Yes. Bijad, do we have any material on this? On not
Yeah,
very hard cover.
I'll take a look. I think there was a session where Mahesh talked about the compact models and like why sometimes you try to like basically enable a model to work like locally on a device. I think it was either on week 1 or week 2, but let me look and get back to you. There might be a lesson on this. I'm trying to kind of like go back off of memory, but we'll check and let you know. If
I think
anybody
in
else
some,
remembers,
I
let's
believe in
share.
some of the reading material, there was
Ah,
some
okay. That
documentation
explains
on it.
that. Okay, great. Yeah, thank you,
Um,
sir.
but I do think it's, you know, just kind of toying around with Vision on Edge gives you a good sense, especially when you start, you know, like running your own inference. Definitely have a sense like, you know, there is some scaling that's happening, and you know, like in what real application, like I'm just doing this for fun, and whether the boxes, you know, are recognized by my doorbell security camera doesn't really matter, but like for your solution, you know, how important is it and what kind of accuracy do you need? So I'll just keep going. I want to talk about the tools real quick that we use. So obviously, I told you that this is Custom Vision. This is an Azure, Microsoft Azure product. So you need an Azure and Custom Vision subscription in order for this to work. And you also need a camera. So I'm using, can everybody see my my screen if I go like this? I'm sure many
Yeah.
of you know what this camera is. This is a Wise cam. It's like a consumer security camera. I do not advocate using these if you do this project. Um, it's a big pain in the butt because these cameras are not very friendly to being used in any other way but connected directly to the software that Wise wants you to use. And what you really need to do is utilize a camera that has an RTSP feed. I actually have, I'll just recommend one. And Chris, if he's on this call, I think this is the one you used, Chris, if you're still there. This is
Right.
this is like a really, I mean, they're both affordable cameras. And if, you know, I just had this at home. So it was, I just didn't want to purchase another camera, but this is just all I had. And it caused a lot of pain and agita because it was not friendly to me accessing an RTSP port. I needed to like revert to a very old firmware that wasn't supported by the company, and I used like Internet Archive to find that firmware, and it was a huge pain. You know, but it ended up working out. If you do take on this project, I would highly suggest this camera. It's very affordable, and it freely offers the ability to access that RTSP port, which is important. The last tool that I would say you need is um, a single Wi-Fi router. And the reason I even mention that is because I was running on a mesh network in my house, and that actually caused a lot of issues because I think it is something about like which access point the camera versus my router was connecting to was giving me some trouble in terms of port forwarding, which I'll talk about in a little bit. I saw someone had their hand up.
I had few questions. First of all, yeah, like why do you think that RTSP is important for CV use cases?
So I can't speak to all use cases, but in terms of the Vision on Edge product, the way that the data is accessed from the camera is via this RTSP feed. So this is just, you know, what Vision on Edge, the product that I used out of the box, needed in order to collect data from my camera.
Got it. So that answers the first question. Second is like I saw you used Wise.
Yep.
Uh, as you know that like one is like training it and then putting in like for work. Like I already have Ring camera. I have Lorex. Have you looked at other cameras also, or like would you are getting the same issues like with Waze? You have to use their software only. Like
Yeah, so the biggest thing is you need to have access to create an RTSP feed. So any camera that has an RTSP feed will work. Wise had opened that as a feature or like part of the functionality that they had several years ago, and then they decided to hide it. And then they decided to remove the firmware from their websites. So I had to revert to an old firmware in order to access that. And Wise is constantly trying to like have me upgrade my firmware. So it's kind of like if you get too fancy of a camera that doesn't readily have like advertised RTSP feed, it could be a little bit annoying, like the trouble that I had with it. But I'll walk you through. And again, I think if you, as long as you look for a camera that has, that says RTSP feed, which this one does, I'm not really sure. I know it's here somewhere, but oh, here it is, right at the top. Yeah, so that's really the most important thing. And I think these cameras are mainly designed to integrate with like third-party software versus using their own software, like a home network, versus like part of what Wise is selling, not to like get too tangent here, but I think part of what Wise is selling is like the software so that it, does some AI trickery for you. But in this case, it was sort of like working against me to have that. So I would just suggest like a less bells and whistles camera that has the RTSP feed. I can't speak to the Lorex and I can't speak to the Ring, but I would just check the documentation and see if they have access to those feeds.
Perfect. Thank you so much.
Yeah, you got it. All right. So the first step, you got to set up your camera. So like I said, I had to run around to find this like old firmware. It was a little bit annoying to find. Eventually I did find it. Once I did that, I was sort of able to like access the feed. So you just kind of go into the camera in your software for if you're using a Wise camera, and you go into the settings. And once you're in your settings, you can scroll all the way down and there'll be this like RTSP feed option. And basically it generates with a private, with the camera's private IP. It also tacks on this like password and username, which I was not particularly creative here. This is like very little security, and you are eventually opening your camera up to the internet. So, I think this is just something to consider. I was less concerned about it just because it's outside my house and I'm not really like keeping this on all the time. But if this is a like more, like long-term solution, I would say this is definitely like a security weak point here. Because if anybody finds out, what the password is, it's, which I think is probably relatively easy to find. You could, have anybody accessing this camera. So, once you have your RTSP feed set up, you need to basically open your camera out to your, to the internet, to the like WAN. So we need to do something called port forwarding. So you basically like go into your network settings. There should be a setting here called port forwarding. I think that is where I was. And, all cameras have like a different port that they're using. I think a lot of them use 554, but you basically are just opening a port with that IP on that port and hitting save, and then you've basically done the work. And you can test it. There's some websites that you can use to test to make sure that the camera's open. And what you would do to test it is you take that link I just sent, the RTSP feed, and you replace this IP with your public IP. And that will open through, and then you got to add this 554 here, and then it will open the camera feed and you'll be able to access the camera anywhere. So that takes care of that. I know that was a little weird. I don't know how many other people have had experience port forwarding. If you guys are into like home security. I feel like a lot of people who do home security think that's no big deal, but just something that I had to kind of learn about. And I know Chris also had similar problems when he was doing this. So after that, once you have the camera set up, you basically are ready to start setting up Vision on Edge. Again, you need your Azure subscription, you need your custom Vision subscription, and assuming you have those accounts, you got to set up the machine that you're going to deploy Vision on Edge on. So this is made to work on an edge device, and you need to use Azure's like IoT Edge service in order to do that. So in order to do that, you have to first set up IoT Edge service on a virtual machine. There is a GitHub that I can link everyone to. I think Mahesh and Bijan have links to like walk you through how to do that. I have it right here. But basically you're deploying your Edge module to your device. So you can definitely use like I said was before, you can use like the NVIDIA Jetson or like another dev kit to do this. I did not have access to a dev kit. I didn't really feel like purchasing one. So I just decided that I was going to use this like virtual, like a Linux virtual machine that you can get easily through Azure. So once you do that, and I'm not going to go through all of this, but it's pretty straightforward. And I think I did this via like the Azure shell, but it was very easy. So once you do this, you need to open a network port to access the virtual machine. So this is my Azure account. And basically what you need to do here is go to the virtual machine, which is this one that I have here, and access the networking settings. And then again, just like you did with the your local network, you basically have to open a port so that you can access this virtual machine via the World Wide Web. So I'm opening port 8181. That's the port that this virtual machine works on. And that's pretty much it. After that, you have to so then after that you install Vision on Edge. Again, this is like some more shell installation here, and I'm not going to go through all of this, but it's like it's pretty straightforward. These instructions are very easy, and once you're finished, you basically waiting. It says 10 minutes, but I think it took an hour for like all of like my runtime status to be positive, and that definitely threw me off a little bit. But I'll kind of just show you what that looks like. So if you go into your IoT hub and you go to IoT Edge, which is the configuration, and basically you want your runtime response to look like this. And as long as you have everything running, which I do, that basically means you're set up. So once you do that, you go back to your virtual machine and you'll get this public IP address here. And the way you access Vision on Edge is you use this IP address with the 8181 port, which is here. And I'm pretty sure all of you could, in theory, access this, but please don't right now because it'll probably time out if we're all on it. But this is basically my live solution up and running. And I'll just give it a little second for my camera to load. There you go. This is really my front door right now. I get this box once a week, and this is empty. And the wind's blowing really hard today, so this is blown down the street several times today. So this is the live solution. You can see this is now running inference. And you can see that, based on the model that I've trained, it thinks this box is, it thinks that, a 94% confidence that this is a box and this is a little smaller. And so this is Vision on Edge. This is what Mahesh has built. It's a really cool, very cool tool. And I'll kind of walk you through all the features here, and please stop me if you have any questions. So when you come here, the first thing you're going to do is you're going to go and set up a model. So there's a whole bunch of like out of the box models that you can get as well, but I set up a brand new one. You can name it and tell it what kind of objects you want to detect. Once you do that, you basically are ready to add images to your model. And this is pretty similar to what you have all seen. There's sort of two sections here. One is like all my tagged images. These actually, even though I have this model trained on like 500 images of boxes, those are all not showing up here at the moment because I've redeployed this model a couple of times, but they're on custom vision. And really what's coming over here is the model and not the original images that I used to train this. But I do have some untagged images here, and we'll go back to this. Actually, we can do that. Maybe it makes sense to do that right now. So here's where you can upload images. These images actually are coming from inference, but let's pretend like I just took some pictures of boxes and uploaded it. You can come in here and you can see that inference says that, it thinks this is a box with 89.79% confidence. It does not think this is a box. But you can kind of go in here and just like draw a square around what is a box. Hold on, I'm just moving something around here. And then you just go to the next image. So that's the same image. And you can kind of just keep going for all your images. I'm going to delete a couple of these. You can see how like there is some sort of like color change in this camera. And, I definitely get different kind of lighting depending on the time of day. And I think working this solution in a factory where you're presuming that the lighting doesn't change, you're going to get a lot better like general accuracy over time. I'm going to just delete a couple of these because they're all the same. Basically, you can set sort of like a threshold. And so that's basically how you train your model. You just kind of go through. Once you have your model, once you've tagged your model with images based on the data that you've collected, you can train it here. This will retrain the model to include, the newest 3 tagged images. I'm not going to hit that because sometimes that takes some time, but you would hit that and then it'll say model is successfully trained. Great. And then you just deploy it. So you go over here. It gives you some options here for deployment. You can select which model you want. You can select which camera. I think you can select multiple cameras if you'd like. And then there's some advanced settings. I don't have this set up, this cloud messages, but you can actually send like video data to the cloud if you're looking to do some video analysis. I was just trying to skimp on the cost for the purposes of this demo, so I did not enable the video analysis. And then in terms of retraining, basically you can set like what percentage confidence do you want to have images being saved. I have between 74 and 90. If you really want to hone this in, you can kind of adjust this to your liking. You can also mess with your camera's frames per second. Sometimes this tool gives you a recommendation in terms of what frames per second is going to work the best. just so you know, I am using CPU here to run this. So this is not the most efficient way to run this tool, but that is just all I had access to. So I would imagine if you're running with a little bit more juice, you could probably up this and run it a little faster, but I know it works and functions well, even if this is all the way down at 1 frames per second. So it is a pretty flexible solution, I would say. Once you have your model deployed, you begin inference, you start to see these square boxes, and then you get these metrics telling you what the success rate of the model recognized boxes in the current deployment. And then as this is happening, it is taking snapshots of the image, and then you can go back and retrain the model by tagging these images that the model has inferred that you have a box. Challenges here, like I said, the Wise camera, I was being lazy, I think, or maybe I just didn't want to spend $35 on a new camera, but it was a bit of a pain just getting that working. Port forwarding on a mesh network, I had to kind of just shut my mesh network down at home. I didn't really have any experience using like the Azure cloud services personally. I'm not a DevOps guy. I was not familiar with like the shell installer. It is pretty easy. It definitely just slowed me down a little bit. I think the biggest thing probably is once I got to training, this tool does say that, like, I think 15 to 20 images, you'll start being able to run inference. But I needed a lot more images to get this to accurately detect boxes. I don't actually have any examples here, but it often, like, I have a squirrel that comes here and it often thinks a squirrel is a box. And that really annoys me because of how many images I have of boxes. But, I think a big part of this is that this camera is facing south. I'm in the northern hemisphere, so I'm getting tons of lighting changes throughout the day. In the afternoon, the sun is right here in the sky, so I don't really think that plays well for the quality of data that I'm capturing. And the best days for me to tinker with this have been like overcast days, or really early in the morning before the sun's up, or very late where the sun's gone down behind the trees on the right side. I think for me, the next step here would be to continue this lab and, program it to send me a text message saying I've gotten a box delivered. I also saw this morning, actually, there was like a farmer in the UK who did this to detect rodents that were infesting his gardens in his farm. So he has them like trained on images of, and it was this exact solution. And he was training it on pictures of like bunnies and squirrels and stuff. And every time it hit a certain like confidence level, he had this like some sort of like hypersonic frequency alarm scare them away. So I think there's some like really interesting things that I've seen people do with these types of like computer vision. And it's, again, I am a non-technical product manager. The fact that I was able to like hobble this together, I think means that anybody here could pretty easily do it. And I think that's pretty much it. Does anybody have any questions, thoughts, feedback?
Anybody interested? One thing I can tell you, from my experience, also just using the custom vision part, like not so much on using the video, but one product that we've also built at PM Exercises, so you might be familiar with it. It's called productmonkey.ai, that basically takes product design files and converts them into engineering task tickets or product requirements. One of the challenges that we faced was how there are so many different edge cases with people uploading files. Like, for example, sometimes the product design files include a modal. Like there's a lot of kind of vagueness in the background, and then there's a kind of a box that is really what's important about that page. So we actually had to use custom vision for the purpose of, for example, detecting whether or not what the user has uploaded was a modal. Then we had to use custom vision to better determine if what the user has uploaded was a form. And then there's like so many different edge cases. Like we have a whole logic in the background that determines what the right set of actions are for creating quality tickets and PRDs based on the result of what we feed into custom vision. So this is kind of an example of this, I think, case that we've actually been able to kind of find custom vision powerful. And in our case, we could actually get to high quality within like 30 to 40 image uploads. So it's usually like, I would say 90% of the time it's accurate, but sometimes the users also like upload like really difficult to detect images. And in those cases, you know, it's hard for custom vision to detect it. But I thought that's an interesting use case. I think a few people, yeah.
Thank you for that. Just to add to that, I will say that I don't have this on this iteration of the model, but if you use like a multi-class for recognizing things using your camera, the model actually runs better. So like, for example, you know, there's like this car that pulls out on the driveway across the street from me that always picks up as a box. But like if I tried to train cars as like a secondary object, and the model works so much better if you can just classify a lot of different things that you expect to see in your data. And then you can filter in and out the things that you are interested in. At least with this particular use case, I found that to be the case. So just to add to what you were saying, Bijan.
Yeah. I can see that Zach and Chaitali posted a question for you as well. I think they're the same. It says, have you tried training with boxes of images at different times of the day and night?
Yes, I have. Definitely. I've tried training at all different parts of the day. At first, I actually only had windows to train at the worst time for lighting. And I was struggling there. And then I realized that the lighting was probably a major factor. So I started training at different types of using data from different parts of the day. So I was able to just capture images, you know, from days where it was really sunny, from days where it was rainy. We have a porch light, so I was also using images with the porch light on at night, and that really helped the model's ability to like have high, you know, predictability on inference for sure.
One of the features that I like about, I think it was custom vision. If the lad is on the call, he might know better. But like, also once it gives you its inference, if you don't disagree, you can actually say to it, look, for example, it was a box or it wasn't a box, and then use that as training, and it basically improves the quality. So I think in a real product management environment, maybe what it turns out to, and that's one thing that we're doing at Product Monkey, is that on a weekly basis, we look at all the inferences, and then sometimes if we see that it made the wrong call, we correct it, and then we ask it to do a retraining model. And that hopefully over time kind of slowly improves the quality as it covers more and more edge cases.
Yeah, I wish I could show you that in real time, but often there are things on my porch that get picked up in inference that are not boxes. So what happens is, it captures those, and you can go in here and just like you would say, to your point, you can say this is a box. So you can go like that. And let's say like sometimes, this house gets detected as a box. You could delete that. And then now this image has been tagged. You can go back and retrain the model. And it, very helpful in improving your results.
I have a question. Hi, I'm Chaitali.
Hi.
Yeah, this is pretty interesting, and I have been working with a few Vision AI products, specifically image recognition kind of things, and made them services for machine parts and those kind of things. So the question is how you handle the data drift here, because often for the boxes, I'm not sure about the use case, but then there are always chances of the data getting drifted. So how often you have been retraining the models,
So I
and
haven't
how?
had them. Yeah. So I don't really need to worry. I haven't had to worry about drift because I just haven't had the model um, running inference for that long. And I really don't have that many, like my data set's really not that large. But I was thinking about that. I think if anything, I could probably use a lot more data. And yeah, drift has not been an issue for me so far, thankfully.
Okay, that's
But I am curious, has that been something you've encountered, and were there ways that you mitigated the drift?
Yeah, so we have encountered a couple of times, and what happens is we were dealing with vehicle parts. So vehicle parts, when they are being taken from different vehicles, specifically even the same make, and depending on different kind of condition they are into, there were chances that they may have slight rust or some kind of deviations or worn out. So those kind of things used to cause a lot of data drift. So we had to go and we have to like each time we had to go and retrain it when the certain precision was not achieved. But then we had to make a pipeline for that. So that was quite tedious initially, but then yeah, the process when it became streamlined with the pipeline, then the overall inferencing also improved and the data drift has been taken care of. Because in production, it becomes very important, right?
Yeah.
You have to have a regular cadence of retraining them in case there is this kind of situations.
Yeah, absolutely. And I'm definitely doing some retraining, but I think if my classifier was something more specific, like a specific type of box, like only boxes coming from, like Amazon or something like that, I could see there being more, you know, it encountering drift a lot quicker, but I haven't seen that as a problem yet. And I think it's just because boxes probably, from a computer vision standpoint, it's probably pretty simple. And not really a lot of like data requirements to recognize, the box versus a different shape. But yeah, once you get into like more specific use cases, I could definitely see that. That's really interesting. Thank you.
Thank you.
Any other questions?
Can't see the chat, so if anybody, I don't know if there's anything in the chat, but
I don't see anything new being posted.
oh yeah, here it is.
Oh, yeah, I don't see anything new, but this was great. Thank you so much, everyone, for joining, and thank you, Adam, for presenting. I think this was a really interesting, I think the custom vision on the surface, it might seem like a very simple tool, but it's so powerful. it's just amazing how much we can do with it.
I
So,
totally agree. I had the same reaction. I thought it was a very straightforward tool. And really, if you
yeah.
go play around with custom vision, you can get so quickly, like without even creating your own model, just pulling up some of the demos. It's incredibly powerful, the things that you can, like the potential the tool has. And it's like in a couple clicks, you can kind of see right out the box. And I really like the Vision on Edge concept. I would love to in the future deploy this like on a dev kit, because I think that would just be, for no reason except for I think it would be cool. But it works well, and there are just so many possibilities now that I have it deployed and reading about the way other people have used this tool or similar tools. It's pretty powerful.
Yeah, and it's interesting how there's like some jobs like radiologists that get paid so well for the whole job of looking at an image and understanding what's going on in there. It'd be interesting to see how this will impact those kinds of jobs over the next few years. Really powerful.
But then
Awesome, great.
X-ray are one
Go
of
ahead.
the difficult. Sorry to interrupt.
No, for sure, go ahead.
X-ray images are one of the difficult most. So I have been volunteering, helping healthcare organization building some osteoarthritis detection kind of models. And the problem what we faced is the similar thing what Adam was explaining, right? If the X-rays were not being taken at certain lighting conditions and a little bit of glare also, even we have all those image processing techniques applied on them, still they are not precise, and the impact of not being precise is quite huge. So it becomes inherently difficult, not involving a radiologist and someone like an SME. Still, the human intervention is needed. When we are
Yeah.
fine tuning it. Still.
Yeah, and the amount of data that you need for like lighting variance is so much more significant. At least for the application that I was using, but I can imagine with X-ray.
Yeah, because you need extremely high precision.
Right.
Yeah, that makes sense. Great. Well, this is a great session. Thank you so much. Thanks so much, Adam, and people that actively participated in sharing their opinion. Chaitali, this is great. Sujit, Ankit, and anybody else who participated by sharing their opinion. This is great. We're going to do more of this. In case you guys are interested in also sharing anything with the community, feel free to reach out to me and we can work through it. Otherwise, I think next week Mahesh will be back. Anything else you want to add, Adam, before we end the session?
No, I just want to thank you guys again for letting me present. And, I'm very excited about this cohort turning into a more collaborative, let's see what everyone's working on. Let's kind of talk about it, kind of opening the floor, so to speak. Mahesh is really and you have unlocked some amazing knowledge, and I love the idea of just like taking it to the next level and getting our hands on some cool projects together as a group. So thanks for letting me participate.
Of course. And I've also shared the link to our upcoming cohort that starts in November 7, I believe. That's the starting date. We're going to have both morning and evening sessions. So the cohort is going to get larger. We're going to have more alumni people. So feel free to apply. Otherwise, enjoy the rest of your weekend and we'll see you next Saturday. Have a good one. Bye.
Bye, everybody.